The Rocky Mountains are North America's largest mountain system, stretching from New Mexico all the way to the northern reaches of British Columbia. They are over 4,800 kilometers in length, have peaks in excess of 4,000 meters, and are a dominant feature of the North American West. Formed 80 million years ago, the mountain range still holds many secrets. As part of its national mandate of scientific discovery, the Canadian Museum of Nature dispatched a team of mineralogists on an expedition that will take them 3,700 kilometers from their home base in Ottawa, Ontario, to the mountain town of Golden, British Columbia. From there, the team will load up their supplies and be dropped off by helicopter at over 2,000 meters above sea level to explore the makeup of the rocks found in the Ice River Alkaline Complex, a unique assemblage of igneous rocks.
We're headed off to the Ice River Complex in Moose Creek.
Their base camp is located near the edge of Yoho National Park on a rocky ridge in Moose Creek Valley, just above the tree line and facing the majestic Helmet Mountain.
So this is Moose Creek. This is Helmet Mountain. That's just to our back. This is the park boundary. This is the ridge line. My name is Dr. Paula Pielanen. I'm a research scientist in the mineralogy section at the Canadian Museum of Nature, and right now we are on the east side of the Ice River Alkaline Complex in southeastern BC.
We're about 42 kilometers southeast of the town of Golden, British Columbia, and we're here to do field work.
It's a tough place to work. You never know what, you can't find horizontal services. It's hard to get here and it's expensive, but it's an amazing place to work. We've seen some amazing outcrops, and a lot of the stuff in the Rockies has been done at a very, very large scale. So people have set foot in every couple hundred meters, took a sample, and nobody's looked at it really closely. So that's one of the reasons we come out here. It's really, really an interesting place to work, and it's exciting.
We're actually not the first museum scientists to be here. Bob Galt and Joel Grice, who are also mineralogists with the museum, they were actually here in 1979. They were on the other side of the complex in Yoho National Park for a while, and then they flew by helicopter over onto this side, and they actually landed in 3 feet of snow when they were here, and that was the end of July. So a little bit different than we're seeing now, but when they collected here, they didn't get as far as we are right now. They kind of stayed a little bit further to the south and actually said they didn't find much. So we've been actually pretty lucky in the last few years. We've found some really interesting material.
So today we took a walk up the ridge to look at some of the later stage igneous intrusions that intruded the Ice River Complex after it had solidified. So we're looking at some of the youngest rock in the system. So the Ice River Complex is fairly large. It's 29 square kilometers. And within the intrusion, there are multiple different types of rocks. And so what's interesting about them is how they're related in space and time and how they differ geochemically.
But see, and it goes right down there. Yeah, I think maybe we should spend another day over here.
An alkaline complex is a geological formation that contains an unusually high concentration of alkaline igneous rocks, often rich in elements like sodium, potassium, calcium, and various rare elements. These complexes are formed from magma that has low silica content and tends to crystallize minerals that aren't typically found in more common igneous silicate rocks, such as granites.
We'll work on alkaline complexes, for a number of reasons. If we can understand the processes that form a complex like this, we can better understand other mineral deposits that are actually much larger in scale and are economic. So the processes, no matter the size of the intrusion, the processes are the same.
It's a unique opportunity to study how rare earth minerals behave in these igneous systems. This is important from an economic point of view. Rare earth elements are often associated with critical minerals, or what we refer to as critical minerals. As we become more reliant upon these minerals for green technology, the ability to locate these in geologic space and determine whether they're feasible to mine is important.
Alkaline complexes in general are known for having strange exotic minerals. And some of the late stage processes that happen after the intrusion is formed and all the hot fluids come through, leftover fluids, and bringing rare elements with it, and it winds up forming some really bizarre mineral assemblages.
So this is a sample of a cyanitic dike that we just retrieved from about 50 meters away. It's a series of interconnecting dikes that are cross-cutting. So we took this sample back because we noticed it's got lots of interesting mineralogy. It's got some adriene crystals, some calcite, some feldspars, and a whole host of other things. We're going to take it back to the lab, cut it open, and see if we can understand how these minerals are interrelated within the rock and within the broader Ice River alkaline complex.
This is a big chunk of sodalite syenite, and you can see all the nice bright blue grains here, and then there's some darker blue in amongst the feldspars here, but it's got some really cool textures. They're kind of longish crystals. That's a little intriguing, and I've actually not seen textures like this before. So this is a good piece. It's a nice piece for just showing off some of the textures, which tell us how the samples, the rocks actually grew.
Unfortunately, bad weather was on the way. Access to the ridge was precarious under ideal conditions, so the summer alpine snow forecasted would have made it dangerous to continue. The team still managed to collect over 120 kilograms of scientific material that was carried down the mountain and shipped over to the museum's collection and research facility in Gatineau, Quebec.
So we're back here in the lab, and we're having a look through the material that we brought back from Ice River this summer and last summer, and it's really, really interesting. This pegmatite that we've discovered is new to science, and it's got some very interesting minerals, and we're going to use all of this material to try and determine how this pegmatite formed and how it relates to some of the other rocks in the intrusion. So in today's world, where critical elements are a major factor in everybody's economy, alkaline rocks are one of the main hosts for these elements, things like niobium and titanium, or the rare earth elements. And the more we work on these complexes, the more we can understand about how the minerals form. And if we can understand how the minerals form, then it's easier to target very specific deposits and to get these critical elements into the marketplace.
Canada is actively investing in the development of critical minerals through various initiatives and funding programs. These efforts aim to establish Canada as a leading producer and processor of critical minerals, essential for modern technologies and the transition to clean energies. Through its national mandate of species discovery, the Canadian Museum of Nature is proud to contribute to the growing knowledge base of our country's mineral diversity and richness.